In this video, we're going to talk about one of the two special kinds of sequences that we will be focusing on this school year. Let's take a look at this first example. Can you identify the pattern in this series of numbers in the sequence that's here? If you look closely, you'll see that going from 1 to 3, and from 3 to 5, from 5 to 7, and from 7 to 9 is all an adjustment of plus 2. Which means our pattern is addition by 2. Let's continue our sequence. The next term would once again be added by 2, giving us 11, followed by 13, followed by 15. We can actually take a look at this and create a rule, so long as we decide that the previous term is going to be represented by the letter N. So now let's look at what's actually happening. If we refer to the first term in here, the 1, as the letter N, being our previous term, what are we doing to that piece to get to 3? We are adding 2. That will give us our next piece. At this point now, we are calling 3 our N. And to go from there, we once again add 2. And so on, we will continue through. This means that this particular sequence has a rule of N plus 2, where N was the previous term. This kind of sequence is very interesting, but not exclusive. Let's take a look at our second example here. What pattern do you observe as we continue through here? To go from 25 to 20, we are subtracting 5. To go from 20 to 15, once again, subtracting 5. 15 to 10, subtracting 5. Meaning our pattern is subtraction of 5. Which means our very next term would be 5, followed by 0, followed by negative 5. Let's apply what we just discussed with N representing our previous term. If we put N to represent our first term, what did we perform? What operation did we perform in order to get to the second term? In this case, each time we are subtracting 5 to get to the next term, which means our rule is N minus 5. Or, we could also refer to this as N plus negative 5. The reason we're also referring to it in this manner is because of the proper terminology for these types of sequences. These types of sequences are also known as arithmetic sequences. And that's a sequence in which a fixed amount, known as the common difference, is added to the previous term. The common difference is the amount that is added to the previous term. Which means if we return to this first example, our common difference is the amount that is added to each term as we continue through our sequence. For this particular sequence, our common difference is positive 2. If we look at our second example, take a look at what piece, what fixed amounts is added to each of the previous terms to get the next term. And in this case, you can see it right here. So our common difference in this particular situation is -5. That is why we wrote this rule in this manner. Because we are taking the previous term, represented by n, and we are adding -5 to it each time as our fixed amount. Let's continue with this by performing some practice problems. Try these 3 on your own. Pause the video and attempt to find both your common difference and then construct your rule. If we take a look at the first one here, we could see that there is a change of 12 each time. In which direction, though, is the question. Are we going in the positive direction or the negative? As you can see, the numbers are increasing, so we have a plus 12, which means our next term would be 71, followed by 83, followed by 95. In this particular situation, our common difference is positive 12, meaning our rule, where n is our previous term, is n plus 12. In the second example, there is a change of 25 from term to term. Specifically, in this case, it's a decrease of 25, which means that our common difference, is -25. So continue with the common difference to complete the pattern. That means our next value would be 0, then -25, and then -50. Once again, following our example for determining the rule, your previous term added by your common difference. And of course, algebraically speaking, we know of a way to refine this and simplify it. So we will write this as n minus 25. Let's take a look at our third example. Once again, we are looking for a difference between all of our pieces here. In this case, we are changing with a decrease of 4. So continuing the sequence here, we'll have -4, -8, -12. Our common difference here is -4. Following the same process as before, the previous term plus the common difference gives us a rule of n minus 4. Pause the video for a moment and try the fourth one on your own. Okay, once again, let's take a look at our difference. Each time we are increasing by 10. Which means the very next term would be 51, then 61, and then 71, meaning our common difference in this particular case is plus 10. Therefore, we construct our rule again, the previous term plus common difference gives us our rule. In the next video, we'll discuss another type of sequence that has a special situation.